Hello everyone, this is assignment 20 and I'm just going to do some select questions on it. If I don't do one that you'd like to see, by all means send in a request and I'll get that done. I'm going to start with question 7. So we're starting with question 7 and I'll just start with A right away. So in this case here, you're given a name for following IUPAC rules and you have to draw the molecule or write the structural formula. There's a few ways you can do it. So I will go over, because I think within the lectures, you've seen several ways of drawing out a structural formula for an organic compound. So it's called 2,3-dimethylpentane for the first one. So the first thing you could do is go along and make a chain. You know, you're looking at your base one. Actually, if I write it down, let's write it down. So 2,3-dimethyl, that should all be together in one word, 2,3-dimethylpentane. So you're looking for your root word, or the one that's telling you how many carbons in the long chain, pentane, so it's going to be 5. So you could go ahead and draw out 1, 2, 3, 4, 5 carbons in a chain, just like that. Now go through and see what substituents you have on them and where. Here's telling us on carbon number 2 and 3, I have methyl groups. So 1, 2, here I'm going to have a methyl, and I'll put it down, just come in this space, and here I'm going to have a methyl. This is not an acceptable answer, though. Just telling you right away, you will receive 0 marks for this. This is just showing you some carbon bonds. But we know that, for example, this carbon here does not just have one bond to it. Remember, with carbon, it's always forming 4 bonds, whether those are 4 single bonds, whether that's a double bond and 2 singles, a triple bond and a single. As long as you can count up 4 bonds to that carbon, you're fine. Remember that whole octet rule? Carbon follows it to a T. So you have to fill in. If it doesn't say what's there, it's hydrogens, is everything that's left on there. And also telling you that it's a methyl or pentane, that means that the rest are all hydrogens. So you would have to go through in this case here and add your hydrogens on. Or you can write it out like this, CH3. Here you have a hydrogen. Here you have a hydrogen. Here you have 2, or you can write it as CH2, also acceptable, CH3. So here I've mixed a variety of styles in there. Either one you want to pick is fine. The other way is to treat that carbon chain and don't actually write any of the carbon atoms on it. So we know we have 5 in the chain, so you can start 1, 2, 3, 4, 5. There's our carbon chain. We know that each carbon, if it's a pentane, meaning it's an alkane, each carbon is tetrahedral, so it's going to be some sort of shape like this right here. Now you'd go through and you'd add your methyls on the 2 and the 3. So here's carbon number 2, there's a methyl, carbon number 3, there's a methyl. So drawn like this, it is assumed that you know how many hydrogens are at each spot, okay? You don't have to write them in when you've drawn it like this. So for example, over here, it just ends like this. Depending on the school of thought, what textbook you're looking at, you shouldn't just end it like this. We're okay with that in this class. But this is a CH3. There are 3 hydrogens on that, because remember, carbon has to make 4 bonds. So up here, you're missing 1 hydrogen. So you will have a hydrogen on that guy. You'll have a hydrogen on this guy. You'll have 2 hydrogens on that guy. Okay? All right, so let's move on and do another one. I'm going to do C. And I'm going to stick to the stick drawings because they're a lot easier, I find. Well, you can do however you want to do it. It's completely fine. Totally up to you. So this one here is methyl cyclopropane. Cyclopropane. So we know there's going to be 3 carbons, but the fact that it says cyclo before that is telling us those 3 carbons are all in a ring. So it has to be like that. Looks like a triangle. And we're told that there's a methyl bound to it. We're not given a number because in this case here, they're all the same. We're not starting, one isn't closer to one end or the other, right? Doesn't matter where you start on the chain. So you can just throw a methyl group on there. And there we go. There's our methyl cyclopropane. And you could write that all out as well. This has CH2, CH2, CH, CH3. Let's do E. This one is 3 propyl 2 hexene. Okay, so a lot more going on in this one here. At the end, hex, so there's going to be 6 carbons in our chain, but there's also going to be a double bond. Okay, that's what this ene tells us. And we know that it's going to be at carbon number 2. So I'm going to draw it out the both ways just because it's hard to see right away. I'm doing this stick one. So 1, 2, 3, 4, 5, 6. I know there's a double bond at carbon 2. 1, 2. And I know at carbon 3, there's a propyl group. 1, 2, 3. Actually, I should probably write it out since I'm doing it. So there's a CH2, CH2, this is getting really small, CH3. And now you would go and fill the rest of this in. This carbon has 4 bonds, right? It has 1, 2, 3, 4. So there's nothing else on this carbon. This one over here is still missing something, so it needs 1 hydrogen. And I've already talked about how to do the rest. So remember, this is not the finished structure. I'm not going to finish it. Keep that in mind, though, okay? Now, if you're going to do this instead using the stick diagrams over here, so 1, and you know your double bond is at carbon number 2. So I'm going to draw that straight across. And now you can either, it doesn't tell us if it's cis or trans. The next question that I do, question 9, we'll see the difference, cis and trans. This one actually doesn't tell you, so you don't know. So we're going to have 1, 2, 3, 4, 5, 6. Like that. There's my carbon number 2. Right there. Carbon number 3. I'm going to have a propyl. 1, 2, 3. Whoops, sorry. Start from there. Go 1, 2, 3. Good. So, is this cis or trans? It's neither, because both substituents here are identical in this case here. So that's why they didn't have to tell you whether it was cis or trans for this particular case. Looking at this case, what is our longest chain? It's one of the questions you want to think of here. 1, 2, 3, 4, 5, 6 is the one we just used. But you can go 1, 2, 3, 4, 5, 6, 7. So if you were given this, why wouldn't this be a heptane? Well, because you need to have that double bond within the parent chain. That has to be included within it. And it's going to start numbering from the side closest to that double bond to give it the smallest number possible. And the last one I want to do is H. Okay. So H is 4-ethyl 2-heptine. So ine is telling us we have a triple bond somewhere in there. Hept is telling us we have 7 carbons. So, and we know that triple bond is happening on carbon number 2. 1, 2, 3, 4, 5, 6, 7. You can add this triple bond after. You can make your 7 carbon chain, then go ahead and add your triple bond. And we know on number 4, there's an ethyl. So 1, 2, 3, 4. I have CH2, CH3. And you can fill that in, no problem. I do want to point out a few things here when it comes time to drawing. Hybridization and geometry in these cases. This C is SP. This is linear, both of those carbons. So if you're going to go ahead and draw this out, you can go there. 1, 2, 3. So that's carbon 1, 2, 3, 4, 5, 6, 7. Okay, and that's what that one is going to look like stick-wise.